Alright, so in this problem, I have 45 to the power of x is equal to 90. So to solve this, I'm going to first start by taking the log on both sides. So now I have log 45 to the power of x is equal to log 90. Now, if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is the same thing as b times log a. So in this case, I have log 45 to the power of x, and I can move x to the front. So now this is the same thing as x times log 45, which is equal to log 90. Now, if I divide both sides by log 45, these two cancel out, and now I have x is equal to log 90 over log 45. Log 90, that's the same thing as log 2 times 45. So I have this over log 45. And if I have something in the form log a times b, this is the same thing as log a plus log b. So now I have x is equal to log 2 plus log 45. Now I have this over log 45. So now this is equal to log 2 over log 45 plus log 45 over log 45. And now log 45 and log 45, these two cancel out. So now I have x is equal to log 2 over log 45 plus 1. And if I have something in the form log a over log b, I can write this as log base b of a. So log 2 over log 45, that's the same thing as log base 45 of 2, and I have this plus 1. Alright, so in this problem, I have 3 to the power of x plus 9 to the power of x is equal to 27 to the power of x. So to solve this, I'm going to first start by rewriting 9 to the power of x as 3 squared to the power of x, and 27 to the power of x as 3 to the power of 3 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So I can rewrite these as 3 to the power of x plus 3 to the power of x to the power of 2 is equal to 3 to the power of x to the power of 3. Now I'm going to let 3 to the power of x equal to y. So now I have y plus y squared is equal to y to the power of 3. And this cannot be written as y to the power of 3 minus y squared minus y is equal to 0. Now if I factor out y, I get y times y squared minus y minus 1 is equal to 0. So this gives me two equations. I get y equals 0 and y squared minus y minus 1 is equal to 0. So for y squared minus y minus 1 equals 0, I'm going to use the quadratic formula. And if you do end up doing it, you should get y is equal to 1 plus or minus the square root of 5 over 2. So my solutions for y are 0, 1 plus the square root of 5 over 2, and 1 minus the square root of 5 over 2. Now remember how we set 3 to the power of x equal to y. So I have 3 to the power of x is equal to 0. This is our first value of y, and you can't take the power of a number and make it equal 0, so this is wrong. Now I have 3 to the power of x is equal to 1 minus the square root of 5 over 2, and you can't, 1 minus the square root of 5, that's going to be a negative number, and you can't take the power of a positive number and make it a negative number, so this is wrong as well. So I'm left with 3 to the power of x is equal to 1 plus the square root of 5 over 2. So to solve this, I'm going to take the log on both sides, so I have log 3 to the power of x is equal to log 1 plus the square root of 5 over 2. Now I can move this to the front, so now I have x times log 3 is equal to log 1 plus the square root of 5 over 2. And if I divide both sides by log 3, I get x is equal to log 1 plus the square root of 5 over 2 over log 3. Alright, so in this problem, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 9 to the power of x. So I'm going to first start by factoring out 3 to the power of x. So I have 3 to the power of x times 1 plus 1 plus 1 is equal to 9 to the power of x. Now, if I simplify this in the parentheses, I get 3 to the power of x times 3 is equal to 9 to the power of x. Now, 9 here is the same thing as 3 squared. So now I have 3 to the power of x times 3 is equal to 3 squared to the power of x. And if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And m and n, well, I can change the place of these two. So this is the same thing as a to the power of n times m. So if a to the power of m to the power of n is equal to a to the power of m times n, then a to the power of n times m, that should equal a to the power of n to the power of m. So 3 to the power of 2 to the power of x, I can switch the places of 2 and x. So now that's the same thing as 3 to the power of x times 3 is equal to 3 to the power of x to the power of 2. Now I'm going to let 3 to the power of x equal to the variable t. So now I have 3t is equal to t squared. Now if I subtract 3t on both sides, I get t squared minus 3t is equal to 0. Now if I factor out t, I get t times t minus 3 is equal to 0. So I have two equations now. I have t equals 0, and I have t minus 3 is equal to 0. T equals 0 is already a solution for t. T minus 3 equals 0, meaning t is equal to 3. So now remember how we set 3 to the power of x equal to t. So I have two equations. 3 to the power of x is equal to 0, and 3 to the power of x is equal to 3. So for 3 to the power of x equals 0, well, you can't take the power of a number and make it equal to 0. Nothing to the power of anything is equal to 0. Now 3 to the power of x equals 3, well, 3 to the power of 1 equals 3. So x is equal to 1, and this is my answer. Alright, so in this video, I'm going to solve the equation 3 to the power of x is equal to 30. So, to solve this equation, I'm going to start by taking the log on both sides. So I get log of 3 to the power of x is equal to log of 30. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. In this case, I have log 3 to the power of x, and I can move x to the front. So I get x times log 3 is equal to log 30. Now that x is an actual term, I can solve for it by getting rid of this log 3. So I'm going to divide both sides by log 3. So then these two cancel out, and I get x is equal to log 30 over log 3. Now, log 30, I'm going to rewrite that as log of 3 times 10. And if I have something in the form log of a times b, this is equal to log a plus log b. So log of 3 times 10 is equal to log 3 plus log 10. Now I have this over log 3. So now this is equal to log 3 over log 3 plus log 10 over log 3. Now log 3 and log 3, these two cancel out, so I get x equals 1 plus log 10 over log 3. And log 10 is 1, so I get x is equal to 1 plus 1 over log 3. Now 1 over log 3 is equal to 2.096, so x is equal to 3.096.